So let's now integrate the message of the previous lecture and the content of the current lecture. As I suggested in the previous lecture, our decisions can be modeled using diffusion model. And can we apply this model for the choice between different options with different values? For these reasons, I will try to focus now on the decision that can have potential costs and benefits. Of course, quite often our decisions are not just linked to certain benefits, but can lead to costs. Even if we select between a cake and an apple, selection of the very nice tasty cake can lead to possible costs, for example, to health problems. So, can we apply diffusion model for the decision, for the selection between two options with potential costs and benefits? Can we apply the same logic of the diffusion model, that brain accumulates evidences for decision 1 or decision 2, for the acceptance of certain decision or for the rejection of certain decision. And whenever the evidence for decision A or decision B, for the acceptance of the decision or for the rejection of the decision exceed the threshold, we make a decision. Can we apply the same logic for the valuation stage of our decision-making process? It looks like we can. So we know that our anticipated gains are coded in the ventral striatum. I gave you numerous evidences today that anticipated gains are encoded in ventral striatum. That even if we will implant an electrode to the ventral striatum, people would stimulate themselves for hours to evoke pleasure, to emulate values in the brain. So we do know that anticipated gains are coded in the ventral striatum. So where are potential costs are coded? So actually one region that is very much linked to the calculation of potential costs is called amygdala. So when a certain choice is associated with potential costs, amygdala is activated. It is activated when, for example, we experience fear, when we are afraid of something. This area would signal us potential costs of our decisions. So I will illustrate it by one experiment. In this case, you see a rat that reacts to a dangerous object, so to a mechanical cat. So you see a rat, and of course, rat is afraid and quickly escape from this open space. But what would happen if we will destroy amygdala, this brain area that calculates potential costs? We will make a look to the behavior of this animal without amygdala. So in this case, we will see the rat, and rat will simply approach the dangerous cat. So the brain in this case doesn't code potential costs. This animal is not really afraid of this cat. So we can apply the same logic as we used in diffusion model to decisions in the context of costs and benefits. Hauke-Häkkinen group conducted a very nice study. Participants learned that certain cues are associated with potential loss and benefits. So for example, color was associated with possible reward, and shape was associated with possible loss. So subject had to make a choice, select one of two possible cues. So to make a correct choice, subject should process expected possible rewards and benefits. This study indicated that the activity of orbitofrontal cortex was proportional to the difference in the activity of the amygdala and nucleus accumbens in this case. So when subject selected one of the cues, amygdala was activated and amygdala processed possible costs of this decision. At the same time, nucleus accumbens was activated, and this region processed possible benefits of this decision. And the activity of orbitofrontal cortex was proportional to the difference in the activity of amygdala and nucleus accumbens. So basically, we now face the same diffusion mechanism. So the diffusion model can be applied to the activity of the orbitofrontal cortex that simply compares evidences for costs and benefits related to certain decisions. And if these costs or benefits exceed one another, we make a decision. So we can apply the same diffusion model metaphor for the choice between options with possible costs and benefits. So from this perspective, orbitofrontal cortex can actually use this diffusion model like calculation of costs and benefits. So orbitofrontal cortex kind of simply compares the inputs from costs-related and benefit-related brain regions. And when the evidences for costs and benefits exceed each other, we make different decisions. To sum up, nucleus accumbens is involved into the calculation of the expected gain magnitude. Orbitofrontal cortex is involved into the comparison of different options and also into the integration of the available information into the broader context. There are other regions that are critical for the decision-making process and also for the valuation stage of the decision-making process. So, for example, dorsolateral prefrontal cortex that is involved into more rational estimation of the expected outcomes of our decisions will be discussed in the follow-up lectures quite a lot. But for today, it is really critical to understand that our preferences, our values are simply encoded in the activity of our neurons. And there are two key brain regions coding expected rewards and also relative reward values that are nucleus accumbens and the orbitofrontal cortex.